Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. This is the Math 8 edition, and I'm your host, Mr. Takeda. I'm going to teach you some algebra right now. This is lesson 4.2, in which we explore and understand what is the slope of a line. So, if you're ready, let's go. Slope, more vocabulary, right? More vocabulary, a lot of vocabulary. Slope is the rate of change between any 2 points on a line. Rate of change, okay? What do we think of rate? We think ratio. And we're going to compare two different things. Comparing two things. Okay? What are we going to compare here? We're going to compare the change in y to the change in x. And see, it's written as a ratio because it's a rate. This is a rate. So where have we seen rates before? We've seen rates in things like the one we've been seeing a lot, of course, is with our distance equals rate times time. So the rate there would be distance divided by time, like miles per hour or feet per second. Okay, so this is the same. So we can that would result in a straight line as well, because it's a slope. So we're going to just look at equations that have these types of things. Let's look at this example here. Over here, the slope is, they're telling us the slope is 3 over 2, 3 halves. And why is that? Because from this point to this point, the difference is the change in vertical direction is 3. Right? The change in vertical direction is 3. Positive 3, going up 3. The change in horizontal direction is 2. We're going to the right. So it's a positive 3 over a positive 2, which results in a positive 3/2 slope. Okay? So the change in y divided by the change in x. That's our big idea. Let's take a look at some examples. Sorry, not examples, just more explanation. More words they use now. Sometimes we'll refer to as a way to remember slope. Instead of saying change in y over change in x, that is actually more mathematically correct. You might hear it referred to as rise over run. Rise, it would be that change in y. See the change in y, it's they're subtracting the y values, and then the run is the horizontal change. They're subtracting the x values. So now we've added this kind of little formula to it. Okay, we'll practice this because what's kind of important here is that we make sure that we use the same point as point 2 for calculating the change in y, and the same point for point 2 that we use for calculating the change in x. So we'll practice that. Some other things we want to kind of talk about here is what's a positive slope. A positive slope goes from it rises, the y increases as x increases. Okay, so as x is increasing this way, y increases this way. A negative slope means as x increases left to right, y decreases. Okay. What if y doesn't increase? Well, you'll get a 0 slope, and we'll look at this a little bit more on a slide coming up. 0, the slope equals 0. Okay. So if this is 0, that's positive, 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 0, negative. Going, increasing, negatives are getting closer to 0, 0, and as the slope increases, we get this way. So this has a bigger slope than this. In other words, the more, I'm going to call it steep, the higher slope it has. And we'll do these measurements later. This is 0, these are negative, this is 0, this is positive. Okay. All right, so now I think we'll look at some examples. I hope. Okay, so here we go. We have some graphs here, and we look at the first one here. It says describe the slope of the line, then find the slope. Well, we can see it rises as it goes from left to right. It rises as it goes from left to right. So this is a positive slope. And then it says find the slope. Well, the slope, we use the letter M to represent slope. And from the point on the left, we have an increase. We have a change in x of 6. Now remember, that's going to go on the bottom, and then a change in y of 5. They have it labeled there for us. Now, let's say we were going from this point to this point. Well, it doesn't really matter, because now I'm going this direction, and that's going to be a negative 6. And then I would go this direction, and that would be a negative 5. So I would have my change in x is still negative 6, and that's over negative, that's under negative 5. So that's going to simplify still to 5, 6. It doesn't matter which one you go it doesn't matter which point you start from and which point you end at. You just have to do the same point for both your change in x and your change in y. Okay, and let's take a look. Let's do this one here, but let's do it with that calculation method. I'm going to call this one here point A, and this one here point B, and it doesn't matter, and actually it doesn't matter which one I do, but I'm going to go negative 2. My change in y will be negative 2 minus 1. Okay, that's negative 2 minus 1. And then on the change in x will be 1 minus negative 1. Okay, so negative 2 minus 1 would be negative 3. 1 minus negative 1 is the same as 1 plus positive 1. So positive 2. So negative 3/2. That's my M. Okay. So that's doing it the calculation way. This is doing it the counting way. All right, so there's some examples for us. Now, on the earlier screen where I was moving the line around, I talked about the slope of a horizontal line. Now, the slope of a horizontal line, if I wanted to calculate it, the change in y, 5 minus 5, and again, it doesn't matter if I use this point or this point first. I have to be consistent for both x's and y's. 5 minus 5 over negative 1 minus 6. Well, 5 minus 5 is going to give us a 0 on the top, and I get negative 7 on the bottom. So if I have a 0 on the top, then the slope equals 0. All horizontal lines have, we say the slope equals 0 or 0 slope. Okay. All horizontal lines, slope equals 0. What about vertical lines? Well, vertical lines, okay, we'll do the change in y first, 6 minus 2, and then 4 minus 4. So this will be 4 over 0. You cannot have a 0 in the denominator. You cannot divide by 0. We'll talk about what it means for something to be undefined in class. But because division by 0 is undefined and calculating the slope for this slope means dividing by 0, that means the slope is also undefined. Okay? Don't get confused now. Don't say no solution and things like that. Slope is undefined. That's the word we want to use here when we have a vertical line. Okay, that's it for this one. There's probably some word problems we're going to go over in class for the rest of this lesson, but those are the examples I want to set you up with. Okay, calculating slope, slope of a horizontal line, always 0. Slope of a vertical line, always undefined. That's it. And great. I'll see you in class, and thanks a lot, and have a great rest of your day. Bye-bye.